Hello, everybody. This is the webinar from the MOU on e-business on semantics and semantic interoperability. My name is Stephen Dannell. I'm the currently this year's chair of the EB MOU. I've just got a few minutes just to put things in context, hopefully, and then we'll get away with the 9 presentations we have today. Just for those people who are not aware what the MOU on e-business is, it was originally created back in towards the end of the 1990s to establish a coordination mechanism to produce mutually supported standards in the area of business transactions. It started with the 4 stakeholders to which we've been highlighted here. That's of ISO, the UNECE, IEC and the ITU. It now has a number of other organizations which actively contribute and participate in our annual plenary meetings. In parallel to these plenary meetings, we also have organized a number of these webinars. I mean, the purpose of them is to try and get together a group of probably who would not normally get together on topics of a common theme. Examples that we've had in the past was one on IoT. Then we've had one on blockchain and distributed ledger technologies, and also one on traceability. So we've been discussing about what was coming next, and we've been discussing about semantic interoperability. Initially from an e-business perspective, but then we realized with all this digital transformation and the growing needs of having digital comprehension, in particular for machines, and making sure that what is sent is clearly what is received, there was a realization that we should be talking to other areas, other groups. And so we pulled together this grouping of interested parties, interested committees and groups in the area of semantic interoperability. I will add very quickly, this is not to say it's an exhaustive group. So if you are working in semantic interoperability and you're not on the list, or your committee's not on the list, it's not a rebuke. This is really to try and start opening up to provide windows between the groups, between domains, and maybe get an idea of what other people are doing and vice versa. This may help to future coordination and insights in this area, which is of growing importance. A couple of house rules. We do have a very busy schedule, so I'm going to be fairly strict on the timing. We've got some presentations at 20 minutes, some even at 15, so apologies for those who got the shorter time. In some cases, we've got lots of slides, so good luck with trying to squeeze them into the time. We do have a coffee break identified at 5 past the next hour, but that depends on how we're doing and whether or not we'll sacrifice that to give other people a few more minutes. For those people who are in the audience, we do have chat, I believe, enabled. And if you have questions during the presentations, it would be a good idea to write those clearly in the chat. If you could also reference the presentation or the number in order, so that if we don't deal with them in this webinar, we can address them afterwards and have them posted on the website. All material, the recordings, etc., will be hosted, will be provided on the UNECE website, and if you need, we can put that in the chat for people to look up later on. So I've already gone almost over a minute, so I will not take any more of your time, and I'll just hand it over to the first presentation, which is Semantics Introduction, Definitions, Importance, Lessons and Achievements by Sue Probert from the UNECE-IEC-ISO-ITU.
Thank you, Kevin. Okay. Super. So, yes, I'm the chair of UNECE-IEC-ISO-ITU under UNECE, and I am representing the semantics work that we have been doing within UNECE and UNECE-IEC-ISO-ITU for many, many years. So the first part of the presentation this first presentation is history up until the point at which the EBMOU started, and it illustrates the early work that we did. And it's all about semantics in the sense of what are semantics? They are a common way of understanding data sent between external trading partners in order to satisfy business processes. In our case, our main focus being the international supply chain. And it's very, very critical that when you receive data in whatever format or whatever syntax, that the receiver can understand what was sent in exactly the same way. So semantics for us have always been important. So briefly, we started in the 1970s. This is even before I joined UNECE-IEC-ISO-ITU in 1994. This was the UN layout key, which recognized the same requirement for common semantic meaning between exchange data, and this was in the light of paper documents. So the international trade standard paper documents were aligned so that the same piece of data would appear in the same place on a form with the same definition, allowing different countries, different languages to be able to recognize data within a paper form. So this was the first step. And next slide, please. Can I move it? Thank you. Yes. So the actual layout key itself was completed and published in 1960 originally, but during the intervening years and continuing today, there are many international organizations who still publish UN layout key documents to support their regulations or their conventions. And there are some examples on this slide. And these are still important documents. And even though we move towards digital transformations, paper is still very present in the international supply chain, as I'm sure you all know. Next slide, please. So this was a physical layout, how it worked. There were certain parts of the form where particular types of data were concentrated, and the definitions of each field within those areas was defined with a particular data element, and that data element had a definition in a new standard, which we will come to shortly. Next slide, please. From the overall structure of a UN-aligned document, there were built over the years many different families of documents where the center changes to refer to the details needed, but the overall design, and particularly the top center, would be the same, whichever family it was. So this was a full range of different documents covering the international supply chain data. Thank you. Next slide, please. And to support that, we had a UN Trade Data Element Directory standard, which was introduced first in 1990. And that is also an ISO standard, which is the ISO standard 7372. This defines not only the name, the unique ID, which is a meaningful ID, by the way, not to have time for that today, but it is meaningful. And then we have the name and the definitions. And not only that, we also have where it occurs on the form, and also which of the international regulations use that field for that data on their form. So it's a very valuable link to the International Convention paper layouts. Next slide, please. And this is indeed a slide to introduce the UNTDD. This is the Trade Data Element Directory that supports the UN layout key. And I've already introduced it, but what's important is that last bullet. It was last published in 2005. An update is very urgently required, but we need resources to be able to do this, and it will be a combined project with ISO TC154. Next slide, please. This is an example of what the UNTDD presents in its standard, and the blue items are normative. There's a non-normative name, which aligns to the core components I will be introducing you to shortly. And the location of bridges on the right-hand side is where there is a rather cryptic but very important link to some of the standard paper layouts for regulations and transport conventions. Next slide, please. The next step for us was the UN-EDIFACT, which was the first electronic data exchange, and this was in fact electronic representations of the paper forms, continuing our work to align to produce a UN-EDIFACT standard, which is the most used standard in the world today. There are millions of EDIFACT messages that are exchanged every day globally, particularly in the international supply chain, and there are over 200 message types, but each one is a complete replication electronically of a paper document. So they are electronic document standards. Next slide, please. So a UN-EDIFACT message consists of a set of messages and then a set of semantics to support it, which is a set of overall structures. And then we have individual data elements and we have code lists. So this was already, even in the 1990s, was quite a sophisticated set of semantics for the international supply chain. So that's the history. And moving swiftly on, because of the time limit today, we then want to move on to what happened in late 1999 and onwards into the 2000s. And this was when XML arrived with a bang and presented itself as the new way to exchange data electronically. What was agreed between the OASIS organization and the UNECE-IEC and CFACT was to start a collaborative project which was defined to finish in 2001. So it was a 2-year project, and that was to define how XML could help to provide a new syntax for data exchange, particularly in the environment of electronic business. In order to, as a result of that project, one of the key results, and it's published as the ISO 15000 Part 5, is the core component specification, also published by UN-CFACT as the UN-CFACT version 2.01 of the core components technical specification. This was a methodology which was developed by the people who worked on the EBXML project, and it was a way of defining globally semantics in the most harmonized way. And I will go into a bit more detail on that. But since the publication, UN-CFACT has implemented the core component methodology, and I will be showing you more about what we have actually achieved with that as we move forward. So thank you. Next slide, please. So this was the joint initiative between OASIS and UNECE, and indeed the EBMOU came as a result of this particular initiative as well. Thank you. Next slide, please. So this version of this methodology for defining semantics is specifically set up to maximize the opportunity for global harmonization of the data structures that are modeled. It is based upon the UML type of data modeling, but it has 2 important additions which make the difference for harmonization. One of them is that it has a naming convention, and there are many, many implementations of UML with different naming conventions that come from the people working with the UML in different environments. What CCTS does is it presents a global naming convention which enables to make sure that data elements are defined following the ISO 11179 data element naming specification. It's an implementation of that. And once you have the name and once you have the definition uniquely defined, then you can move forward to modeling the data in a way that will have a lot of harmonization built into it. The other thing that's really important about for the core component technical specification is that it works on 2 levels. It introduces the 2 levels of modeling, which I don't believe any other modeling methodology adopts or has yet adopted. This means that we have a lower level of classes which have no business context. They are built up over the years. Whenever anybody wants to add something they need in a business environment, then we make sure that it is added to the underlying set of non-business context classes, such as person, address, transport equipment, that type of thing. Apart from the actual class itself, there's no other business context. And that means that whenever someone submits something new to our core component library built on CCTS, it means that we are able to check with the underlying classes to make sure that we are not adding something that's already there or other aspects of harmonization. So that's our base harmonization layer. On top of that, the core component library that we've built uses the second level, which defines business information entities, which are reuses of the underlying classes, but with added business context, and they can be restricted, they can be specified more exactly for the business context, but they are always based on the underlying core component. So those are the two main things. Next slide, please. This highlights what I've just said. The first layer are the basic building blocks with no business context, and they are made up of classes with simple and complex attributes known as the basic core components and the associate core components for linking core components together. Thank you. Next slide, please. When we move to the next layer and we have the business information entities, then we add the business context, and the types there are the aggregate business information entities. They are the ABIEs, business information entity classes, and within them, again, you have simple and complex attributes. Each one of those is always based on the underlying base core component. Thank you. Next slide, please. So I did highlight the highlight the naming convention, and it is an implementation of 11179, which I believe has updated since, but it was the one that was available when we were developing core components under the EBMOU project. The last point is important for us, and that is an experience that we have gained from the fact that our words, when we have multiple words, we don't use camel case. We don't squash them together in any way, because that stops you being able to use spell check. And spell check is one of the things that we can use as one of our weapons to maximize and increase the quality of our core component library. So it's just an important point to mention there. Next slide, please. The next slide shows we do, as I say, adopt the OO tripartite data naming, element naming from 11179, and this is an example that would be the lower, the basic core component level, where you have an object class term, a property term, and a representation term. And you can see an example there, country name text. Thank you. Next slide, please. So here we have some more examples here, which gives you an example of the types of object classes. Again, this is at the lower level of the base core components, and you have information there about the property terms and the representation terms, which are often called the data types. These 10 data types are normative within the core component technical specification, and any semantics that use those 10 means that they are automatically more harmonized. Well, they harmonize better with other standards if you can have these common. I can give you an example. The WCO data model uses exactly the same 10. It isn't the same in its modeling methodology above the base 10, but the fact that the base 10 are the same gives us a way of harmonizing with their work. Thank you. Next slide, please. Finally, we come to how we implement the core components technical specification. And this is our UN core component library. And it is a semantic library, very large library now, of e-business constructs based on the core components, technical specification. And it's an exchange syntax neutral library, which is an important point, because as different syntaxes come along, as different technologies come along for sharing data, then this provides us with something that is independent of the data exchange syntax and is a common basis for any implementations for different syntaxes that come along. And then the extension by restriction is an important but quite technical implementation of specified by the core component technical specification, where you can qualify the reuse of a simple attribute in a base core component by adding more business context. This is something we could go through in more detail, but we don't have time today. But it's a very big flexibility, and we only extend by restriction so that we don't add anything that isn't already covered within the foundation, and this is the most important point. So we have a mature, stable, and trustable library developed over the years, as I will show you just now. It's available free on the UNECE website. And what you can see in this diagram is that the blue section at the bottom is the base core components. And what you can see quite clearly here is that they are very stable. We don't often have to add to them. It's a very strong range of classes for reuse. And then you can see the business information entities, the red section, is growing and growing, but we're not having to add to the base layer. So this indicates the harmonization that we're achieving by using this. The green layer is the messages, and the top layer is the data types for codeless, but we won't go into that right now. But it gives you some idea of the extension and the size of the core component library since its first publication in 2006, which was 50 base core components only. Thank you. Next slide, please.
Sue, just a warning, we've only got 1 minute left.
I haven't got too many left now. Okay, so very quickly, and this will be repeated in the later presentation, we found it necessary to define what we call semantic anchors. So this is the base, some of the base concepts that need to be assumed by all of our core component library and included in it. So semantic concepts as anchors are really important. Next slide, please. And equally, parties, their names, their roles, and within our scope of the international supply chain, this just provides you with some examples of not only defining parties and roles, but also how they relate to each other. This again is background for our core component library. Next slide, please. We do relate all of our new work to all of our former work, and this slide shows how we relate. It gives you an example of the naming. And the next slide, please, gives you an example of how we link to the UN TDD, which I introduced earlier, and the UN layout key, and the UN codes for EDIFACT. So you can see here that we build into our core component library links to all of our standards. So we bring all the semantics together. Thank you. We contextualize the ABIEs. I don't need to go into that in detail. This is the reuse. This is for your information. And at the bottom, you can see that we have 4 views on the international supply chain, one from the trade perspective, one from the transport perspective, one from the cross-border management perspective, and most importantly, the extensions either side to cover ESG sustainability in the most modern work that we're doing. Next slide, please. This again is the inheritance levels, which you're very welcome to look at and be interested in. And please contact us if you have any examples. But this shows how we restrict to specify particular contexts and how we relate everything together and how we manage the core component library and the reference data models that are based on it. Thank you. Next slide. This is how we manage the extensions to the library. Our project teams, when they decide what data information entities they need, they look at the library. If it's not there already, they will request and submit new structures. And the next slide, please. This is how they do it with a wonderful spreadsheet, which can be mechanized. And this is something that the library team look at and use as the basis for seeing whether we can include all the submissions or whether some are already there, but we do the harmonization at that point. Thank you. I think that's my last slide.
Yes, and I'll say to the audience, if you've got any questions, please put them in the chat. If you can't do the chat because you don't have access, you can always send it to either some of the contacts you may already have in this group, or if not, try sdu@iec.ch. Thank you very much. We're short of time. We don't have time for anything else, so I will move it to the next speaker, which is from ISO TC 184 SC4, the Palace project, and we've got Leo van Rujven. I apologize if I badly pronounced, to let you go. And once again, I'll try and be sharper with the time. Is Leo there?
He's talking. He's on mute, Stephen.
Mute.
Can Kevin, can you unmute him?
I'm now there, I suppose.
Perfect. We can hear you.
All right. To share. All right. So indeed, this is a presentation of the 184 SC4 community industrial data. A little short, my background from the EPC contractor in the Netherlands in building construction, a member of SC4 industrial data, initiator and editor of the ISO 15926 part 11, a member of USPI in the Netherlands. This presentation is about the replacement of a nuclear facility and a medical isotope production facility in the Netherlands, which is to be replaced by a new one in 2030. In fact, it's a €1.5 billion project. It's a quite big project, and it has to be delivered in 2030. And typically for industrial data, the problem is that we have this is just a one-off project, and in one-off project we have a challenge in information management by means of the fragmentation over disciplines and parties in such a project. We see that several parties involved in such a project has their own design and construct processes and use their own tooling, but we have to cooperate anyway. And each of them, in more or less extent, uses systems engineering according to 1528, the system lifecycle processes, but they do it all in a slightly different way. So it's quite difficult to communicate with each other in an ambitious way. So what is left, in fact, is that we have to exchange information between the parties in such a way that every party can do his work effectively and preferably in one time wide. So in this project we use the information exchange we do based on semantic standards to be sure that we understand each other in a correct way. A second challenge we have is the fragmentation over time. We see that in such projects we start in a world of say as required, stating what is required to be there, including behavior, design basis. The second world, in fact, is the as designed world, where we do the design and engineering. And the third world is what we really, the facility are building, say we materialize the design. And the problem, in fact, is that those three worlds are quite isolated from each other, because in each world there's another organizational structure. There are used other technologies, and also semantically they use different models, different terms, different definitions. So that's the reason why we have a challenge to assure that the three worlds are communicating with each other and understand each other. In this project, we introduced a common data environment according to ISO 19650, the BIM standard. based on the 1596 ontology, in fact, where we incorporate the 3 worlds into one common data environment by cleaning the data from each world and harmonize it according with the ontology. In this case, we derived from the 1596 a specific Pallas ontology, which we use to harmonize the data between all parties involved. The structure of if you look into the common data environment, you need structures to organize your data, to organize the information. So we recognized 8 main structures: a document structure, requirement, the system and product breakdown structure, a geographical breakdown, function, process, work, and organizational breakdown structure. And we defined relationships between the elements of those structures and defined properties on each element level. And the relationships we defined in the ISO 1596 Part 11 ontology, where we have, say, 250 standardized semantic relationships, including domain, allowed domain and range, which is used to make a clear representation of the whole facility over all disciplines, over the whole life cycle. And secondly, we use a reference data library to classify each element in the document's breakdown structure to say what it is. So what kind of pump, what kind of valve, what kind of pipe, whatever is can be found in the reference data library to standardize all the type of things we use. And still we have documents, so we relate the document structure in with the document management system and the 3D model based on the IFC standard. We connect all the 3D objects to the system breakdown and the geographical breakdown structure. So this is in fact the whole structure, which can be found in the common data environment as data representing the whole design and later the whole materialization of the plant facility in data in the common data environment, all classified and all connected with each other with standardized relationships. Also, we have the problem of the life cycle, introducing the life cycle, the asset life cycle. So we have also based on the 1596 and 1763 European standard, semantic modeling linkage standards, which recognizes that you have planned functional entities, mostly the things that you can find as symbols on the drawings, which are implemented by planned technical entities, the design represented by the 3D model, and at the end, based on the data, the specification data, we buy things and install, and they start to perform, hopefully, according to whatever was planned functionally. So you can say that the physical thing is installed at the place on the drawing. Sometimes it's called the functional location. So in that case, you can also record when the pump is exchanged by another one because it's broken or end of life, which the new pump will be installed in that functional location, and how that pump is performed during the life cycle. So this makes it possible to really trace back how things has performed over its life cycle, but also when there is a change, either in the physical world or in the design world or in the functional world, what you have to change anyway to make it all possible to do a robust configuration management. We use for the basis of the ontology are the W3C standards like SCOS, RDFS, and OWL. So we in the standard we recognized the function of those 3 W3C standards, and we used for the RDL the combination of SCOS and RDFS, and for the integrated information model we used just plain RDFS to model the ontology. And on the level which OWL and Shekel, you can say, so for information verification and inference, we used just Sparkle to fill in those capabilities. So in this project, we intentionally did not use OWL just because of simplification reasons, and also that software cannot handle OWL on this in this case in such a project. The upper ontology is what I said is based on RDFS, just ending up in the RDFS resource. We have an RDFS class, property, and statement, and we have the possible individuals are all either a physical object, an activity, an event, a state, or an information object. And we defined as an extension on RDF property a set of, say, 200 semantic relationships, all defined by domain and range. In this case, for instance, is whole 4 as an example of such a relationship. And then we start to instantiate this ontology on the project. So, for instance, this is an instantiation of that relationship. A is a whole for B, pointing to the relationship and pointing that A and B are instances of the corresponding class in the upper ontology. So we can, in a small example, we have project data like we have a pump XIZ, which has a relationship with a room, arrangement drawing, and a work package. And it's defined, the pump is defined as a functional physical object, the room as a special location, and the arrangement drawing is a document, and the work package is an activity. To type it as an entity of the upper ontology. And we further classify it as something in the RDL, the reference data library. So the pump, in fact, we classify it in this case as a vertical centrifugal pump. The room is classified as an engine room, and the arrangement drawing is a general arrangement drawing. So we have, in fact, for every individual, it is typed 2 times, 1 according to the information model and 1 times according to the reference data library, to make the data really explicit and traceable, and it can be validated if the relationship is correctly used, in fact, by looking at the instance, where it is an instance from in the upper ontology, in this case the functional physical object, and the spatial location which defined the relation is within. It is, you can check if that is correctly instantiated. This is how it looks like, exactly the same example in the graph database. We use a graph database tool to put in all the data, where you can find the pump XIZ is a type of IAM, a functional physical object, and is classified as a vertical centrifugal pump according to the RDL, and the other elements you can just, so it becomes a really readable storage. In fact, it can be read by human and by computers. So it's human readable and computer readable according to the information model and the reference data library. The problem we have to solve, in fact, more organizational, is the fact that we have the various disciplines like civil, mechanical, electrical, instrument using their own tools like Revit, SolidWorks, P&D tooling from Bentley, Aviva, whatever. And we have to take care that we take all those tools use their own ontology, their own model and their own terminology, which is not harmonized. And the tools can also have a very bad interoperability, in fact. So we only can extract data from those tools, clean the data, harmonize it according to the information model and the reference data library, to be sure that we can, in the common data environment, we get a real correct representation of the whole design over all disciplines. For that, we need really knowledge to do that. You cannot ask that from engineering. They are not, they don't have the skills to do that. So we have a separate team, an information delivery team, according to ISO 9650, which handle this this process to clean the data and harmonize it and classify the data. Ending up in data that is really representing and is, the engineering that can be feed back to the engineering disciplines to use as a base for the further development of the design, based on a common sense of the common representation of the whole design. And at the end can be handed over to the client as one really consistent and harmonized representation of the whole facility. That can be will also be the start of the asset management phase and the operational phase of the facility. So we have, in fact, also according to the 19650 standard, the work in progress phase, which is in the tools, the shared status shared between the disciplines, and the published, which in fact represent the baselines taken from the design and engineering. We introduce for that, say, really a car wash. We call it a car wash for data, getting the raw data sets from engineering, any engineering tooling, checking the correct syntax, a reference of all codes, numbers, etc., drawings, rooms, equipment, tag codes, etc. And we check if the codes really are allowed to exist in the CD, if they should. And we start to harmonize the semantics according to the integrated information model. We classify all things according to the RDL. We identify additions, changes, and deletions with respect to configuration management. And we check the validation rules for applying the correct usage of relationships, specifically looking at the correct domain and range of each relationship used in the data. Ending up in a really a common data environment function as a single source of truth. This is also based on the ISO 8000 data quality standard, which is quite an important standard for us. Ending up in cleaned and signed named graphs, representing the data sets, and they're all also stored in the CD, so we can really roll back the whole common data environment to what's ever imported in the common data environment. And the same we did for IFC models. In fact, this is the non-graphical data coming from all engineering tooling, calculation tools, drawing tools, and we have the same for the IFC models. So this is ending up in a kind of digital ecosystem for managing engineering and facility lifecycle data, having the work in progress represented in engineering data. And the data is extracted from those legacy engineering tools, cleaned and mapped to the information model in RDL, and put in a common data and shared for the old engineering processes. Based on the WL3C Sparkle standard, we can extract lists in form of Excel or Power Apps. And based on baselines approved by the client, we push the data into a CD published, which is the baseline data, which can be used by the client to work with his business process on it. This is not. It's quite ambitious and innovative approach of doing projects, and you see that it really needs on the information side to really select, tailor, and implement data standards to develop an IAM and RDL. It's really an iterative process. You see that when the project is moving on, it grows, especially the RDL. The reference data library will grow when you go further in the project. You have to focus on the information streams. There are, in this kind of project, a lot of information streams between disciplines, between tools. You have to identify the main ones that really are important to manage your data, manage the information. check the models behind them and their owners and stakeholders, and agree on exchange requirements between the tools and the common data environment. You have to apply the principle of ISO 8000, so that recognizes syntactic, semantic, and pragmatic data quality. It's really important for that. The technology, we use semantic modeling technology to cope with the rich system engineering data. You cannot do this anymore with traditional databases. It's impossible. And you have to select a flexible linked data platform capable with hand-to-handling named graph. And we use reified triples to be able to do configuration management, to do really replacements on triples that have been changed in time. Of course, we have to use open standards and open source technology, because we have to deal with the fact that, say, within 20 years, we know for sure that we will have to do a migration to technology that at that time will be, say, there. And we have to agree to assure that the content of the common data environment really we will be able to hand over, in fact, at that time to any technology, whatever, then will be there. And in fact, I think we succeeded in this mission by just limiting ourselves, in fact, to just only RDFS, the W3C standard, combined with Sparkle. That was really, which made it doable for engineers and for our IT people to understand the whole mechanism and to understand the software you use.
Leo, we have reached our time.
Yes, this is the last.
Very quick. And then
yes, this is the last one. This was the last one. So human organization is really the most important. Vision, support of senior management, competence renewals, and we have really to bridge the gap between ontology and engineering environment. That is also, there is a really big gap between, say, the ontologists and engineering environments and engineering tooling. We have to integrate the domain knowledge, semantic modeling knowledge, and IT. So that was really in a short time.
Everybody's in the same situation, but thank
yes.
you very much. And there's a lot of information in each one of these slides, all the presentations today. I've put this for everybody in the audience. If you do have particular questions to follow up, then if you are unable to use chat, I have put my own email address in there, and you can send them directly to me, and I'll make sure they get addressed by the various people, and the plan is to post them up on the UN site with all the other material. But it looks like in all of these sessions, we're not going to have any questions. We're not going to really have the time. So I do apologize for those people thinking they were. And I will rush through. It looks like we're not going to have time for the coffee break. I would like to be able to distribute some of that extra few minutes. We're already running, I think, 5 minutes late, but just to give a heads up. So without further waste of your time, the next presentation is from Steve Capel from the UNECE-IEC on semantic technologies. And I will leave that. I'll pass it over to you.
Thank you so much. Hope everyone can hear me. I'll try and give you back some time and be quick about this. Let me just check that everyone can see the presentation. Are you seeing a full screen peek into the future?
We're seeing the distributed slides, so you got the first slide and the next slide shown. So if you can change your display slightly.
Switch displays. There we go. Yeah. How about now?
That's a lot better. Thank you.
All right. So this is builds on Sue's presentation. To discuss a little bit about what the future might look like for supply chain data integration. I'm going to run through this as quick as I can to give you some time back. But before I look at the future, a very quick summary of the history. UNECE started in 1957 and developed a whole bunch of trade facilitation standards that were really paper-based. Probably the most famous one is the layout key. Recommendation number 1, and it's why waybills look so consistent around the world, because for however long it is, since 73, nearly 50 years now, there's been a very consistent paper layout standard. Subsequently, things like low codes for locations of ports and logistics locations around the world. And then the digital era started with a standard called EDIFACT, which is pre-internet, a very, very lightweight messaging standard that is still actually probably more used than anything else today in supply chain. So it shows how slow things move. And this is about the same time that UN-CFACT was established under the UNECE umbrella to look at digital standards for cross-border trade, supporting all the regional commissions, of which UNECE is only one. And a period of the last decade or two has developed early digital into what I might call current digital. So the core component library, XML naming and design rules, reference data models, eDocs, and so on that Sue was talking about earlier today. And a very recent trend towards really focusing on traceability and transparency in supply chains in order to align with UN development goals. So that's the history. But what I'm going to talk about for a few minutes is some speculation about what might be next. So first of all, a quick note that I think the number is something like 2% of ocean bills and airway bills are digitized today, maybe 5% of invoices. In other words, after all those 3 or 4 decades of digital transition, we're still dealing with an awful lot of paper in the cross-border supply chain. And what is digital is still largely EDIFACT. And so that iceberg with a little XML tip on the end probably is a not unrealistic representation of the state of play in digitization of the supply chain today. So at this rate, 3 decades to get a few percent, it's probably a century if we don't change things to dramatically increase the level of digitization. Why is it so slow? Well, many theories, but one of them might be because it's quite expensive and complex to build integrations. And so smaller players don't do it. So maybe we need to think differently and ask what opportunities emerging technologies offer. And so it's a little bit of a peer into the future, but to quote William Gibson, the future is actually already with us if you just look in the right place. So rather than invent the future, I'm just going to pick 3 technologies that I think will have a significant impact on the rate of digitization in the cross-border supply chain, right? And explain why. So the first one, the previous speaker touched on, is linked data vocabularies. If anyone's wondered why it is when you Google something like apple pie, you see such consistent looking panels like the 3 you see in front of you, despite the fact that the data for those panels comes from very different websites. If you click on the link and go to the website, they all look completely different. So how did Google make 3 very consistent looking panels with nicely organized information, despite the dramatic variation in the source data? The answer is linked data vocabularies. There is a quite well-established vocabulary called schema.org. It's not a UN-CFACT product. It talks mostly about organizations and parties and apple pies and the like, so not so much cross-border trade. And it describes, or it provides really a language for tagging any source data, whether it's a PDF or a website or whatever it is, with semantic meaning. And that means that you can you can ingest data irrespective of its structure and just pick those semantically tagged elements and make meaning of them and arrange them, as Google has done here in the apple pie recipe, in a consistent way. So what does that mean for data integration in the supply chain? Well, it may lead us towards an opportunity to transition, where possible, from today's integration paradigm, which looks something like this, right? I have a system, I want to ingest or export data, whether it's a purchase order or an invoice or a waybill or whatever it is. There's a reference schema with a description, and a developer has to build some mapping between their backend system and some standard schema. And every single document and every version of every document is a development effort. So it's not an inconsiderable amount of work and quite costly. However, if documents are instead, or in modern world, maybe even IoT data feeds, are tagged semantically from a consistent vocabulary, then there is an opportunity to transition kind of from design time integration, build a thing in advance and then ingest the documents, to more like runtime integration. Give me any data, and as long as it's semantically tagged, I can make some sense of it. Right? So that should have a significant impact if used appropriately to reduce the cost of some integrations. I'm not saying it works for everything. Some data is really transactional and you need to understand the complete schema. But I think for a lot of applications, semantic tagging and ingesting data based on that should provide a dramatic reduction in the cost of integration of data in the supply chain. So that's number one. And in order to support that, what we've done is taken the buy, ship, pay vocabulary that Sue presented and published it as a linked data vocabulary. I think I've got a bit of time. I forgot to start my timer, damn it. I'll just click on it very briefly. Maybe not, I've got to swap displays again to show you. Am I? Sorry. Swap displays. I don't know, that's not working. Anyway, you can click on it yourself. What you'll find there is, are we looking at a full screen again now? Web data vocabularies?
We're looking, I think, at your CFAT Web Vocabularies web page.
Okay, right. Oh, it did work. I don't know what was going on there. Okay, so this is the web data vocabulary, and it extends on things like schema.org because it's addressing supply chain use cases. So we can look for things like consignment. It's got a search capability. Behind this HTML rendering is, of course, a JSON LD linked vocabulary. But here you can see all the UNCFAC designed properties of a consignment and look at the meaning of them. And all of them have a URI anchor. So these are all tags that can be attached to any data in order to understand it and browse it at your leisure, but it's all machine readable and downloadable. Now let me figure out how to go back to my slideshow.
Yep, that's
right. We're back on the slideshow.
Indeed.
So the next piece of technology that's quite interesting is something called verifiable credentials. We're getting newer as we go, right? So this next technology is a bit newer than the old one. There's a W3C standard describing this. Why is it important? Let me just quickly describe what it is. So it's a portable, it's a data model for a verifiable portable packet of data, a bit like a driver's license or a degree certificate that is issued by some accredited issuer to a holder. And this is a really important concept, that the data is provided from whoever issues it to whoever is the rightful owner of it. So if it's an invoice, it's from the issuer of an invoice to the buyer. If it's a driver's license, it's from the state authority to the holder. And these verifiable credentials are digitally signed by the issuer and also human renderable, so you can look at them as if they were paper. It's up to the holder to pass it to whoever needs it. This is a really important distinction between the typical EDI exchange where systems talk to other systems. In this case, the data is issued by an accredited issuer, given to a holder who then presents it to whoever needs to verify it. And because it's got this dual human renderable and native digital characteristic, the same verifiable credential can be either used manually, look at it, have a look at it, scan the QR code with your phone, verify it, or ingested in a fully automated way, as if it had been sent between those two machines directly. So UNCFAC's written a white paper on this. It's built on W3C standards. But what it does is really provide a very scalable way for the actual exchange of data. Why is that important? So a little picture here of a typical supply chain, in this case from mining to electric vehicles. The blue dots represent islands of information, and it's massively simplified because obviously around the world, there's not a dozen of them, there's thousands of them. And each of these blue dots represent maybe a traceability platform or a SAP platform or something, an ERP that contains data. The actors in this supply chain need to exchange data between themselves across national boundaries and across industry sectors quite often. And the systems are not necessarily aware of what the next system is. And so it becomes very difficult to achieve this level of integration by connecting systems, because if there are 1,000 systems, that's plausibly 1 million integrations between different systems. Whereas instead, if each system just provides its data to the natural owner, who then passes it on in the supply chain and provides it to the next system, then you've really mimicked the natural flow of data in the supply chain and avoided any dependency on system-to-system integration. So this magic trick will break a barrier of scalability that should really see a very significant increase in digitization. And again, UNECE-IEC supporting this technology by building some open source capability and linking that to the vocabulary that I previously mentioned, because the content of these verifiable credentials, of course, has to have meaning. And the way to achieve that is to populate the content of those verifiable credentials with terms that are drawn from a standard vocabulary, such as the one I showed you in the last slide. So onto the third and more recent technology trend that I think will have a plausibly dramatic impact. We're talking here about AI and large language models, and many of us know this as ChatGPT. But that's just one example of a large language model, and OpenAI is the language model behind it. So these things are like massive translators. It's actually very similar to how Google Translate works. By indexing pretty much everything on the web, a large language model learns how to map almost anything to anything. And as a consequence, it's quite a powerful way to absorb any data source, structured data, unstructured data, semi-structured data, or structured data, in almost whatever format it's provided, and ask the large language model to make sense of it and map it to your favorite vocabulary, such as the UN Trade Data vocabulary, and then pass that data into your system in a way the system understands. In other words, what's happened here is that instead of the developer either developing an ontology and manually mapping to it, or developing those schema-based integrations, they're basically asking the large language model to make sense of the data object that it's provided, and then translate it to the structured data format that the system needs. So you've kind of automated all that expensive developer work. Now, this is very recent stuff. There is a fair bit of work going on, as you'd expect, in this space, and it's eerily competent and accurate in the experiments we've done. And all I can say is it's not 100% accurate, but it's only the beginning of this trend. So it seems not unlikely to me that it won't be far away where large language models can bridge that final gap and make sense of any data and translate it into the format you need. I don't have a UNECE-IEC reference for this yet, although we have just started a project that will leverage large language models to try to make sense of the literally thousands of sustainability standards around the world and the hundreds of sustainability criteria that each one has in order to develop a harmonized vocabulary. And you just got to Google things like data extraction from PDF using OpenAI or some such term, and you'll find a number of hits. So the wave has started. I think it will only get more and more competent and may dramatically change the data integration paradigm as we know it. Why does this all matter to UNECE-IEC? Because UNECE-IEC is part of the UN, and there are things called Sustainable Development Goals, and CIFAC's mission is to align with those sustainable development goals and deliver the digital standards needed to achieve sustainable and resilient supply chains around the world. Currently, there is a surprising amount of, and there's evidence from this, of ESG claims that are fake or misleading. That's called greenwashing. and also a quite high proportion of consumers that actually expect better and are willing to pay for it. So we find ourselves in a fork in the road here where if ESG claims are easy to fake and consumer confidence drops, that lower confidence will mean less and less price differential and less margin for even well-intentioned businesses to transform the way they work. That's called a race to the bottom. What we want to achieve is a race to the top, where it's hard for businesses to fake claims. Therefore, consumer confidence improves, higher prices are justified, and businesses compete and motivated to make stronger and stronger provable claims. Now, easy to say, hard to do, needs a lot of digitization, and we can't wait a century for it. So these three technologies that I've described are being experimented with in order to facilitate an inversion of that iceberg so that we can achieve a very high digital penetration quite quickly in order to basically win the race to the top in the greenwashing battle. And UNECE-IEC will increasingly organize itself around that theme by positioning sustainability criteria in there as one of the key deliverables to build on top of the supply chain data models that Sue presented and that we've rendered in semantic web form to basically facilitate adoption around the world of digital standards in the lowest cost way so that they become ubiquitous enough that it actually works. I don't know how I'm doing for time, but I rushed through it fairly quickly. Maybe I've managed to bring you back on schedule. I don't know. You've given us, I'd be happy to accept them.
You've given us an extra 2 minutes, and I'd rather, if we could, given the amount of more presentations, if we could move to the next one and really ask if people to send questions, like I say, either put them on the chat or send them direct to me, and I will forward them on to you later on, if that's okay.
Mm-hmm.
Oh, okay. Apologies. We should have made this twice as long with lots of time for people to interact. This is really a snapshot for all those people presenting and for those people listening. The other thing is for people to send any suggestions about what to do as a follow-up. We'll be talking to the presenters later on regarding that. The next, I'm going to avoid a coffee break. I do apologize if you were looking forward to that, and move straight on to the next one, which is the semantic vision from Hanan Becha. I apologize if I've pronounced your name incorrectly, from UNECE-IEC-ISO-ITU.
Thank you very much. Glad to join you today. I do apologize because my voice is not normal. I'm still on vacation. So probably I did abuse a lot.
I didn't realize your voice changes with vacation.
And I think Kevin is sharing the screen. I'm still seeing the slides loading.
Yeah. Yes, we've got your slide on the screen. Your first slide.
Wonderful, thank you. So we did prepare a lot of slides. We'd like to share more with you, but clearly we don't have enough time to go in a lot of details. So we'll be having all the information shared after the event with all the slides. And basically today I would like just to present and highlight how we do work within UNECE-IEC-ISO-ITU, how we use our core component library, how we use our reference data models and business requirement specifications, development methodology in order to deliver our different standards. I'm doing this presentation as the Vice Chair for Transport and Logistics. Next slide, please. I don't see the following slide, Kevin, yet.
We do. We're now on slide 3 at the moment. The supply chain process model.
Perfect. 1 second, please. I see one slide, but that's okay. I have my slides as well, so I do believe that we could do that in parallel. Okay, so basically we did work on different recommendations. So the first one was mentioned by Steve, the well layout key and aligned document families. The second generation is really all the UN EDIFACT global document equivalent electronic message structure. And the third generation, we are working on the data exchange independent semantics document. So basically it's XML publication. And now we are working on fourth and even fifth generation. So the fourth generation is reference data models for use in both process-driven and document equivalent exchanges, basically working on and delivering GSON's schema. And now we are working really on RESTful API to be able to exchange data. So we are really using the UN Core Component Library in reference data models view of international supply chain and providing common semantics for the use for multi-institutional projects which develop UNECE-IEC business standards. That means regardless of which generation we are developing, we are still using the first generation, which is basically the different definitions for the different data elements required for the supply chain. In terms of UNECE-IEC Core Component Library, we do really cover the whole supply chain, the buy, ship, pay. So our standards cover from the preparing the export, then the transport, the import, and the import, which means we really cover the commercial procedures, the transport procedures, and the regulatory and financial as well. So recently we have launched a new project to cover the different required document, working with banks and insurers to make sure that we have digital finance, digital trade document shared paperless in a paperless way. When we focus about on the supply chain, we do really cover the sales order contract. So we talk about the different actors, the different roles, and the different required documentations and contract. Beyond covering all these data elements and different processes, we are really having a holistic view and approach. So the information is not really purely related to goods or purely related to transport or regulatory. We are really creating the links between the different information sets, which is part of the global supply chain. And we have really a holistic approach in the sense that we have cross-industry, multimodal, and cross-border management included. All our point is really to be able to make sure that we do simplify as well the international supply chain, which is very complex, involving multiple actors and multiple relationship and data exchange. Why this work is very important? We do believe that we are really aligning the semantics between the trade and the transport. And we are really supporting the information sharing. So we are enabling, for example, the data pipelines with the timely captured information, with a good quality captured at the origin source, and ensuring the supply chain visibility. We are trying as well to reduce as much as we could the administrative burden by efficient reuse of data shared across the international supply chain. So the data is shared by the data, let's say, creator, shared once, and available at this kind of pipeline to be shared and reused in a very efficient manner. We do believe as well is the common semantics, the common definitions, the common structure of the data are really the basis for implementing data exchange syntax in an efficient way. The way that we do work, we really have the UNECE-IEC Core Component Library, which is more than 1,300 data elements. Then we really, based on the context, we define a subset. For example, the buy, ship, pay subset, reference data model, is barely less than less than 400 data elements. Then we do really cover at the level 2 of the different context, the supply chain reference data model, which is around 140 data elements. The multimodal transport RDM, again, 100, probably 50 data elements, while cross-border management, 87, as I have noted here, data elements. And finally, when it comes to sustainability and ESG goals, we are around less than 200 data elements. The fact that we do focus our work and we do drive our different subset based on the core component library, we have this super data model that could be reused in different contexts. So we simplify by selecting the subset relevant for a particular context. And we have the certainty that we are not duplicating or reusing different data elements that have the same meaning with different definition. So the different contexts are really using whatever we have in the core component library. This is very important. We are not just approaching document by document in a very disconnected way. We do develop the core component library, and then to make it simple, for example, for the e-bill of lading, so we restrict the different subsets until we have really the data elements required for the e-bill of lading. If tomorrow we're working, for example, we would like to cover the document, let's say letter of credit, we don't have to go through the process of redefining the different parties or redefining the structure of the address, for example. We do really reuse the same thing, and we have kind of alignment between the different views, whether it's trade or transport. We do focus and we do use the same data elements, which makes it easier and even faster in different development. So this buy, ship, pay really covering the different subsets for the different mentioned, let's say, context. Let me quickly cover what are the recent transport and logistics achievements. So we do have this buy, ship, pay reference data model, very, very important, easy to use, making sure alignment between the different contexts. We did as well deliver the cross-industry supply chain track and trace standards. Basically here, this project is one of the very, very few projects that we don't really add or enrich the core component library. We didn't need to add any new data elements. We are simply reusing what we have. And the main message is the importance of the use of unique identifiers. And the main importance as well is linking the different identifiers. So the inclusion of this project in particular, we don't really need to make sure that we have one, let's say, identifier used for the air, for the route, and for the maritime industry. We could simply link the different identifiers by creating a collection of different events. We are able to do this track and trace from really the product, the goods, transport means, etc., until the delivery of the goods, basically. White paper overview of blockchain and trade. This is very focused on blockchain and the impact of the technology for trade. We have as well the white paper on verifiable credentials that were mentioned earlier by Steve. Cross-border management, RDM, and as well during the COVID, the pandemic period, we were really, really active, and we did initiate a project called UNTTC, which is basically electronic transport data exchange structure based on MMT. And this is where we did really launch, for example, the e-bill of lading that were used by different organizations, namely DCSA, FIATA, and BIMCO. So we were able to make sure that the different organizations, even though having different focus, different view, bulk, maritime, and freight forwarder view, three of them are aligned because they did use the outcome of UNTTC, the e-bill of lading definition delivered by UNC-FACT as a basis, as a draft, and from which they did really select what they need. Cross-model dangerous good data harmonization, when it comes to dangerous good, is very complex. Different regulations depending on the transport mode, etc. And we did really work on this cross-model dangerous good, which we are quite proud, even though it's complex. I did mention this UNC-FACT cross-industry, which is basically being able to track and trace any product, any assets, and share the information in standards format. So basically, when it comes to the visibility of the goods, we are trading and having the visibility of the box, the pallet, the container, even when they are empty, and we are taking into account the different technologies, whether it's IAS tracking the vessel, whether it's smart containers, RFID, OCR, etc., just name it. So we have different digital streams covering and enabling this track and trace for cross-industry supply chain. And thanks to this track and trace, we did really work on addressing the gaps in multimodal transport cases, since we have different IDs used in the rail, the road, maritime, and air, as I mentioned earlier. Okay, so the importance of events were highlighted, the importance of IDs were highlighted, white papers usually are the initial points when you would like to learn more about the UNECE-IEC deliverables, because really they are only around 20 pages, very high level, explaining the concepts for C-level people, decision makers. When you would like to get more into the details, then BRS, the business requirement spec, give more complete description. Okay, so what else I would like to highlight? All the slides will be shared. All our deliverables as UNECE-IEC, you can find them on the website. So we really have, you don't even need to register, you don't have to sign in. We have all the standards really available on our website for free in a very simple way. And usually, as I said, we have the BRS, we have the XST schemas, the UML diagram, XLS guideline structure, spreadsheets, and HTML. So we do publish in different formats to make sure that are accessible depending on the need and the way we are working on them. Steve did highlight as well all the different formats, including JSONs and JSON LD, to make the life of developers much easier. Finally, I would like simply to encourage you to register as an expert. It's for free, a very open process, and it allows you as well to contribute at your own capacity to UNECE-IEC project. We do really work having always in mind UN goals, and all this ESG and sustainability is really at the heart of what we are achieving. So all experts are welcomed to join the standards development process work for free of charge. Please feel free to contact us, either through the chair of UNECE-IEC, myself as UNECE-IEC vice chair, or Kamula, UNECE-IEC secretariat. Thank you for your time. I was really rushing into this presentation. I know we are short of time, but again, this is really an invitation to join us, connect on UNECE-IEC website, or reach us even on LinkedIn if you have more questions beyond this chat. Thank you.
Thank you very much. And with your rushing through, I would also reiterate we will be providing these slides on the UNECE website after this webinar. It also means in total we managed to recover 15 minutes, which means that the last three presentations, I'm pleased to say you're going to have 20 minutes and not just 15. Hopefully that's a lot fairer across everybody. Apologies for not spotting that earlier. Obviously, if anybody wishes to have their presentation time shorter, that's always very welcome. But without further, before I go into that, obviously, if you've got any additional questions, I see one or two going through the chat already. But please send them, write them on the chat, or send an email to me, and I will forward them on. So we move on to the next presentation. That is Semantic Interoperability and Digital Transformation from Laurent Guise from the IEC SMB SG12. Thank you.
Okay, Stefan, thanks. Can you hear me?
Loud and clear, and we can see your slide in the correct format.
Okay, so Stephen has introduced the fact that I will speak on behalf of the IEC strategy group number 12 in charge of digital transformation. So next slide. One way to address the digital transformation actually is twofold. One way is to consider the need of the society to really perform its own digital transformation, and then which means use of data exchange and so on. But it's also the digital transformation of the standardization bodies themselves, which needs to either improve their efficiency, but as well to deliver digital product. So currently, IEC SG12 is addressing both aspects. So the question of supporting the digital transformation of society stakeholders, which mean data exchange, communication exchange, processes, digitalizing processes, but also cybersecurity attached to all of this. And now regarding the digital transformation of the bodies themselves, so of IEC, but working very closely also with ISO and other SDOs. This means working on the transposition of what used to be the product of such body, which are standards, into digital format, their virtualization, increase the efficiency in producing these digital elements. So, of course, both aspects are linked, and this is what will be in the next slide. Stefan, yes. So currently, I'm just highlighting here 3 task forces of this strategic group. Task Force 1 is mostly working for improving the internal efficiency of the standardization body of IEC thanks to digital means. Task Force 2 is focusing on the transposition of the deliverable of IEC into digital product and services. And Task Force 3 is mostly focusing on semantic interoperability and also on the structure of these digital elements. And of course, as it is shown on the graph, this Task Force 3 is just in between both aspects, which means that feeding the society with standardized semantic on one side, but also consuming potentially this standardized semantic in order to form the future digital standard. So this is one of the challenges that is in front of us, is that we see that more and more both aspects will be linked. They are currently not that much linked, but will be linked, which means as soon as a product, a technical committee, for example, on a product will publish a product-related standard, it will consume de facto the standardized semantic element which has been defined for this product. So this is today the main goal of the Task Force 3, and then we will get into more details in the next slide. Yes, this is Task Force 3 currently relating to the semantic interoperability has a project, the writing of 3 different reports. The first one is mostly, I would say education, which means that the introduction of semantic domains. And thanks, we see here a draft table of content of what will be in explaining what semantic interoperability is. So it is not absolutely a given. There are plenty of domains which are currently quite far from the question of digitalization, or they feel that they will not be impacted by digitalization, while we believe that all technical entities in standardization will be impacted ultimately by digitalization. So education is really one very important point. This is the purpose of this first report, which will be concluded by an identification of the main challenges. We will come back on that. What are the main challenges from the standardization body itself related to semantic interop, handling semantic interop? The second report that we expect to deliver is a set of recommendations to adapt the standardization ecosystem in order to better support the building up of a standardized semantic domain. Again, it is not a given. Yes, we have already many technical entities which have already produced their standardized semantic domain or namespaces. but they are still facing plenty of issues. So what we would like through this second report is really to get through the whole, I would say, life cycle of a standardized semantic domain, how to create, how to manage, the content or to manage a relationship between semantic domains, how to use it, how to maintain it, and so on. So getting through these use cases, we expect to identify the main requirements from a standardization body perspective. And this will lead to a set of recommendations to the management board of IEC to improve today's situation and facilitate the building up, the spreading, the distribution of standardized semantic domain. And among the improvements which we already believe are absolutely necessary, this is the purpose of report 3. The report 3, next slide, is about providing already guidance, I would say, to non-digital experts on how to manage a standardized semantic domain. Again, we believe that 100% of the technical entities of IEC will have to face or already faces the question of digitalization, and then we would like to guide them in order to improve their own internal efficiency. So this is why we, for example, we introduce the notion of namespace. The namespace is the place among a given semantic domain where a term, a data, I would say, or a semantic element is uniquely defined. We strongly believe, for example, that those namespace should be managed as close as possible to where the knowledge is, which is not that given, that easy today. We may have, for example, today situations where for a given product or a system, operation is mostly handled by one technical entities, while the specification is handled by different technical entities. So you guess that having this type of organization doesn't favor the building up of consistent semantic approaches between both. So this is the purpose of Task Force 3, is really to provide guidelines on the way a standardized semantic domain should be managed. So next slide is about, I believe, the challenges. Yes, we have already identified challenges for standardization bodies such as IEC to really elaborate and build standardized semantic domain. The first challenge, I would say, is the speed. Most of the management of standardized semantic domain is incremental, and this is not, I would say, the normal way of addressing standardization today, which is mostly one shot. So here we need to implement, and it starts being the reality, but more agile processes to address the setting up of semantic domains. The second point, which I have already started speaking of, was to favor the reuse. Today, the siloed organization of the standardization ecosystem is, as it is said here, a real obstacle to favor the reuse of existing semantics. So we don't have, for example, any kind of governance to push for the reuse of existing semantics to prevent inventing new data while they are already existing in other domains, or to reuse, as it is shown here, abstract concept which can be specialized in different structure. So this is today the reuse is really one barrier. It is absolutely not given. Just give to you an example. So you have a technical entity dealing with multiple Okay.
Laurent, your audio's gone quite bad. Is it possible to maybe switch off your video? That might help with the bandwidth.
Yes. Okay. So I was mentioning is it better, Stephen?
Oh, you need to speak, but it seemed to be starting to be better. So yes.
Okay. So I was giving an example that favoring the reuse is not that easy. And I was giving an example of comparing a wind turbine on one side and electrical vehicle on the other. You would state what are the commonalities between both. It happens actually that both can behave like an electricity generator. Of course, a wind turbine is producing electricity, and an electrical electricity. We should favor, as an organization, the relationship between both in order to converge on the same set of data for that facet, I would say. So now we need also to work on agility in build-up and maintaining these semantic domains. So it's close to speed, but now it's really from a process perspective. How do we address this incremental aspect of semantic domains? Tooling is also a very big issue because all of these data are of IT based. So how to specify these new type of artifacts? How to check the validity, the conformity to some semantic rules and so on? How to produce? We've just seen that, for example, rendering may be an issue, which means that we, as a standardization body, a standardized semantic domain may have to be rendered into multiple different language, XML, RDFS, OWL. So how a standardization body can manage that? Maintenance, versioning, publishing, also there are plenty of difficulties that are in front of us as a standardization body to ensure at the end that standardized semantic domain will be managed in a good way. And last but not least is distribution. So how to ensure an easy access to such semantic standards, how to facilitate the redistribution, how to enable the modification or the profiling. So it was mentioned, I think it was by Sue Robert, the extension by restriction. So how do we facilitate such extension? So there are plenty of questions regarding distribution that needs as well to be addressed. So these are the challenges that we know are in front of us, and we expect through this initiative of SG12 to improve today's situation. And at the end, yes, the conclusion is, well, semantic interop is really at the heart of this IEC Strategic Group 12. We have seen that we have four main objectives: to educate the standardization stakeholder, to adapt the ecosystem, to better support it, to provide guidance to technical entities on how to best address such digitalization challenge. And we have a fourth one, which is to address new experts because they need to be digitally minded. It is not a given. And we have already seen, it was part of the introduction, that this is also a strategic aspect because the standardized semantic domain will, at the end, influence the way standards will be produced. So we need really to be very efficient in managing this specific aspect. Okay, that's all for me, I believe, Stephen.
Yes, thank you. You're short on time, which is great. I see there's a couple of comments in the chat. I think Hiroshi, you're raising some other additional considerations when you start looking at distribution of content, and I guess that's an even more interesting subject. I would like to continue with our fast pace on the various the timings. I did my maths wrong, so now we have 20 minutes per each of the presentations left. So if we move into the next one, and once again, any additional questions, send to me or put on the chat, and we'll post them later on. So next on my list is introduction to what semantic interoperability means, its principles, and how concept systems play a role, from Denise Wurzel. Over to you. Are you there, Denise?
There we go. Yeah, I had trouble finding the mute button.
Okay.
Okay. So let me go ahead into presentation mode so that the slides are easier for folks to see. Is that coming through as a slide as opposed to?
Yep, that's perfect.
Okay,
yep.
Great. So first of all, very pleased to be invited to speak and have enjoyed all of the talks. I'm learning quite a lot and seeing some similarities across these organizations and their approaches to achieving semantic interoperability. I'm the convener for the ISO working group for metadata standards. And so this is all very near and dear to my heart in terms of semantic interoperability. I also work full-time as the National Cancer Institute's semantic infrastructure manager, responsible for our metadata and models strategies. This is part of the U.S. National Institutes of Health. And so my talk will be slightly different because I'll be talking about the challenges that we face in healthcare. Okay, so let me just briefly introduce my agenda. I will define semantic interoperability from our perspective, but I can see it's very similar to what others are saying, and so that's great. We'll talk about the interoperability issues across healthcare research and biomedical research, and the lessons learned and challenges and approaches that we've been trying to use over the past 20 years. One of the key things for us that we have found is that there's a very important role for concept systems. And so that's kind of the core of my talk, is how semantic interoperability can be achieved using concept systems. So first, just again, revisiting the definition agreement that it's the ability of computer systems to exchange data with clear and unambiguous meaning. In order to achieve this, we feel that there are some basic principles. There need to be standards for data exchange. You saw many of the folks talking about what those might be, such as XML and JSON. There need to be a shared semantic alignment and mapping. I think Sue talked about level 1, and others have talked about a common core. And that kind of shared semantic alignment is extremely important and can facilitate mappings across different domains. We also feel there needs to be rich metadata that goes beyond just names and definitions. And some of the folks have talked about ontologies and how that can provide that richer context. And in various ways, people have talked about governance among the stakeholders, agreement to use these established standards, and a way to manage changes over time. So we think these are some key principles that we have adopted and are continuing to apply. So you might ask, why do you need semantic interoperability in healthcare research and biomedical research? This shouldn't be a surprise that scientists need data to conduct research, and that that research can drive new cures and treatments. And so it's vitally important to the health of our nation and internationally. Currently, there is a lack of interoperability. A lot of domain-specific studies are done, and yet the data that is so important and expensive to collect is not easily shared or integrated. The reason this is so important to change is that a lot of diseases don't occur frequently in the population, but yet they're significant and important for us to address in terms of cures and treatments. So therefore, there's sort of an underlying demand for aggregation of data in order to increase the confidence in the findings. And so making those findings more higher quality and giving us greater confidence in them. We have some interoperability inhibitors, same as everybody else, different data models, different coding systems, and different terminologies. So this slide, I'm going to outline the approaches that we have been taking in this healthcare and research domain, and the challenges and lessons learned from them. You've heard a lot of talk about ontologies, and it's been a hot topic, maybe last 10 years, maybe longer. But there are some challenges with this. They're highly specialized. It takes highly specialized skills. I think those of you attending this conference probably have the right skills. But when we come into the healthcare domain and medical research, these people are scientists. They are not IT specialists, and yet they want to create ontologies. And the few that can, it is still very difficult to use them. Once you've developed them and published them, there's special query languages like Sparkle, and there are very few people who know how to leverage those. The other problem was that the excitement over ontologies has now resulted in over 1,051 ontologies that are now published by Stanford University in something called the BioPortal. Let me just take a quick minute to see if I did not intend to be doing this as a black face, no, I'm not, I guess I probably forgot to turn my camera on. I'm sorry. If you can do that from your side, Steve, feel free to do that. Okay, so the other problem with all these multiple ontologies, if you've ever tried to map across ontologies, you know that it is very expensive. Again, special skills required, error prone. There's often not one-to-one mappings, and some concepts just don't exist in the target ontology. So ontologies have not really helped us realize interoperability in any sort of scalable way. The next thing we thought would be a solution is common data models. Let's just get everybody to use the same data model. This has been, I'll just say, not feasible, if not impossible. You can get groups, subsets of groups or silos who agree to use the same data models. In healthcare and healthcare research, for example, one of the major inhibitors has been that we have these major electronic medical health record companies who have their own proprietary data models that are not interoperable. And then healthcare research, there are at least 4 what are called common data models, but they are not interoperable either. Some of them are names some of you may recognize: OMOP, Coronet, Sentinel, and there are others. In biomedical research, we have a similar problem, but they tend to be domain-specific data models, for example, to study genomics or proteomics or cancer specifics, like lung cancer or ovarian cancer. They all have their own data model, and they repeat data elements in them that are found in the other models, and they collect them differently, they name them differently, they use different coding systems. So it's really a huge problem that even though we thought common data models would be a solution, it really has not turned out to be as such. And then the third area is we thought, okay, well, if everybody uses the same terminologies, even if they don't have the same data model, maybe that will achieve interoperability. But we still then again had, with no governance around this and no central agency or someone who would say, okay, we already have a terminology like that. We've seen a proliferation of terminologies, over hundreds of them, and they're not fully aligned. The National Library of Medicine in the US has tried to do mappings across these different terminologies, but so have other groups. And so not only are they not fully aligned, but multiple mappings exist by different groups, and that makes it hard to interoperate. In the biomedical research domain, we have the same problem. This is just an example to illustrate this kind of problem. On the left-hand side, you see a healthcare research data model called OMOP. It looks fairly straightforward and simple. But then when we took our biomedical research data elements that we designed for COVID research and tried to map them into an OMOP data model so we could possibly store the data that we've been collecting in OMOP, we found this sort of spaghetti of what we might call imaging, needing to use several different tables and contents of device and procedure. And it just gets very, very messy to try to aggregate data across data models that are as significantly different as these. So what do we do? At NCI, we actually had started down this path back in 1999, I think, and our approach was to leverage ISO 11179. I've heard others mention that. Beyond the naming convention, there are various parts of this registry that let you collect information to describe your data. The structured metadata and the ISO registries allows you to collect accurate and reliable information about your data. It's a prescribed structure, and I think Sue put up a slide that was similar to this, showing the different components that you can use to describe your data elements. They all have unique identifiers in a registry. And then data interchange can reference these data elements, and they can put them into collections like data sets and data models. But the key component here is that the semantics of the content in an 11179 registry are based on concepts. And I'll talk a little bit more about concepts in a moment because that's one of the emphases of my talk. Concepts are assigned to these things called object classes, which are kind of similar to tables or classes in a class diagram, and then also to the properties, the columns and the attributes. So those of you who have described your own common models can see some parallel in sort of breaking these things into two parts, and both parts are reusable and combinable in different ways. And then the third piece of this, from our perspective, so that the data itself can be interoperable, is to assign concepts to the permitted values, or the actual, in some cases, you have an enumerated list of things that can be used to populate that column. And those pieces of data also have concepts associated with them. So this registry creates a set of rich metadata. There can be multiple names for these objects, multiple definitions. They can be in different languages. And this can facilitate interoperability across different groups. Okay, so I'm going to spend a moment on concepts and its role in semantic interoperability. As most of you probably know, concepts are ideas. They're units of knowledge. And for them to be useful, they need to be formed together into something that we call concept systems. We have another standard in our working group, 5394, that talks about the criteria for concept systems and describes how they're formed. They're composed of terms and definitions. They're generally domain specific. For them to be useful in interoperability, they need to be human and computer readable, and they need to provide semantic clarity. There needs to be context. If they're done right, they can enhance the understanding of the data. Beyond synonyms and roles and relationships, we have this thing called the semantic spectrum that has arisen out of the community. The further up to the right you go, the richer the concept relationship types are, and the more expressive the semantics are. So from the lower end, where you might have a list of terms that gets reused over and over, or a glossary, to the upper end, where you have a more sophisticated concept system called an ontology, and you can use reasoning languages to reason over the data that's been linked to those ontologies. Here's an example of a data element that's been represented in 11179 with concept annotations. This is the ethnicity data element. And this is a busy slide, although some of your slides were much busier, so I don't feel too bad. If you look at this, I've got the three different domains across the top. The red is representing the healthcare research, the healthcare domain, which is slightly different. That means the data that's in an electronic health record system, as opposed to healthcare research, which is data that's been extracted from a healthcare system. And then we have biomedical research domain, which the data is normally collected in a clinical trial in a different kind of data system than what you see in the EHR. And so, again, we have this separation of data models that are really designed for, they're purpose-driven. Data models are designed to help you answer the questions that you need to. And that's part of the basis why they're so different across groups. So as we look across this, I'd like you to follow the green, which is sort of where this starts. We take that data element and we annotate it with the concepts that describe that class and that attribute. So in this particular case, if this is ethnicity, then there's a person involved and it's their ethnic group. And that consistent semantic then is applied to these four different data models: the PROCORENET data model, the OMOP data model, the HL7, which is healthcare data model, and the CDIS data model, which is for clinical trials reporting. And I've placed the names that are used by those data models in blue, just to show you that the names that people use in their data models are different as well. You can't always tell. This example looks a little more straightforward. You might be able to search for ethnicity by name and say, okay, these are the same. But if you raise it up a level and you search across these data models by their registered semantic annotations, they would all have this concept code of C25190 for person and the concept code for ethnic group. And then by that mechanism, we can tell that the data elements are similar across these data models. The next important part, too, on the left-hand side in orange, is the concepts that define those permitted values, those enumerations that you often have for columns that help you validate and populate databases. So in this case, my slide has lined them up by the semantic meaning, so that concept code in the first column has a standard term or name. And then the number 3 just shows across the row that if you were to pull back data from these 4 data models, and in one case you get a Y, another case you get this number 3003563 and so forth, you wouldn't be able to tell that they mean the same thing. I don't know how much machine learning you could try to throw at this. It still wouldn't know what those meant. But once you tag it with that concept code and you use those identifiers, those concept identifiers, language independent, data model independent, then a computer can tell that these 4 data values actually mean the same thing, and the context of their meaning is a person's ethnic group, and so it makes the data much more semantically interoperable. Okay, so the role of concepts in semantic interoperability is that it establishes this shared meaning across disparate domains. It enables knowledge discovery depending on the sophistication of your concept systems. We can go beyond synonyms, relationships, and roles. We can include different languages. It enables data transformation, as you saw on the other slide. It would be fairly easy to see that all those 4 data values meant the same thing, and you could convert them to whatever representation you want so that the data can be aggregated and then analyzed by systems that require the data values to be the same. You can also discover across different data models where you have the same entities such as a person, ethnicity, and be able to transform that data more easily. You can also organize the data better for comparison purposes and publish that data as linked data so that it can be used by machine learning or AI algorithms and represented in graph databases. So NCI's approach has some critical components, and I'm seeing a lot of commonality now that I've seen your other presentations. We call them different things across these different presentations, but basically there's this common semantic model that supports harmonization and mappings, and there has to be agreement to use this common semantic model instead of everybody doing their own thing. This has been facilitated for us by the Office of National Coordinator for Healthcare in the United States, and they have basically mandated a set of classes and attributes that all of these 8 healthcare vendors must publish. Even though their internal data models are different, they have to publish their data and for these classes and data elements in the same way. So that establishes this common semantic model, which we have not had before. We also have determined that we're going to use a shared concept system for semantic alignment. And because the NCI has a specialized group of experts who create our terminology, it's called the NCI Thesaurus. It's really much more than a thesaurus, but it covers concepts not just for cancer, but for pretty much all diseases and domains within biomedical research. And we can control that. We have governance over it. We have a very quick turnaround for creating new terminology and a highly reliable and trusted team of expert lexicographers and terminology experts who can create ontologies. And so it's a very rich resource for us to rely on, and we can continue to iterate over time and grow this resource with more terms as they're needed. They're also linked into the National Library of Medicine's UMLS system, where they have tried to map across terminologies, and we've decided to use that as an authoritative source for mappings from our system to other of these standard terminologies that are 100 or more that have already been established. And then we're going to use this concept system to annotate this common semantic model. So we'll have the model that describes the classes and attributes, and then we'll have those concept annotations that I showed in the earlier example for person ethnicity, so that we can run off of those concept identifiers instead of depending on terms, which sometimes can change. And then the central governance idea is really critical amongst the stakeholders, so that there is agreement that people will register their data models and let our experts map them to this common semantic model. This ensures that there's consistency in the applications of the concepts that have been used in the semantic model, and that we get a structured set of metadata that is common across the different data models instead of each data model having to map to itself. The common semantic model that I talked about from the U.S. Office of the National Coordinator for Healthcare has a name. USDCI is the short name for it. And I've just got a snapshot of the data classes and elements that are included there. I guess you could call this our core set of elements that are expected to be collected. This was initially developed for healthcare, and we are expanding this to include the information that's needed for research, such as specimen information, imaging, and so forth. This model is going to be registered in NCI's 11179 metadata registry. Again, the concept annotations will come from the NCI Thesaurus, and that will allow us to map across disparate data models to this common semantic model. I talked about the shared concept system being another key component, and that the NCI thesaurus is our chosen system for that. This is just to illustrate that it is much more than just a terminology or a thesaurus. It does provide the ability to discover that there is more about a particular concept than just the concept itself. Its relationships to other things. For example, that the concept of adenoma may have cytogenetic abnormalities in these 3 different chromosomes. You wouldn't get that if all you had in your data was the fact that they had an adenoma. So that linkage to the concept system gives us an entry point into a much deeper knowledge base. And so, in summary, really, the semantic model has been chosen instead of the common data model approach. It gives us shared semantics, which provide clear and unambiguous meaning, independent of anyone's data model, and enables mapping and transformation. So what you see on the right-hand side, the different colored bubbles are intended to represent different data models in different domains, and that they all will be mapped to a hub instead of being mapped to each other, which is going to greatly reduce the disparities that we see when we get multiple people mapping their data models to each other, making different decisions, and then the data is still not interoperable with other groups who have done their own mappings. We annotate the semantic model with shared concept systems. We registered in an IEC 11179 registry, and then we use the concept systems to enhance knowledge discovery. These are references that I've talked about in my slides, and I would encourage you to go there for more information. I hope I kept to the time, and I turn that back over to Stephen, or questions.
Oh, well, unfortunately, we don't have a chance. You used all your full 20 minutes, but you didn't go over. So thank you very much. It was very informative, as a lot of them have been. And I also just like to add the possibility of, given what has been talked about already and what is about to be talked about, it may give the possibility for those speakers to contact the other speakers to see if there's any cross learning, ideas of, I don't know, solving obstacles or providing lessons learned. But I will leave that to you to initiate. Next on my list, so I've lost my place. Is now the presentation on Systems Committee Smart Cities from Michael Mulkin from the IEC Systems Committee of Smart Cities. Thank you. Over to you, Michael.
Thanks very much indeed. Brilliant. So thanks to everybody else for a really solid foundation that you've laid. We're kind of really building one on the other, and I feel very much I'm building on what's gone before. If we could go to the next slide, it's important to realize that I know nothing. I always say that as chair, my role is to get other people to do all the hard thinking and just try and understand it and shape it. And I really want to give due acknowledgement to some of the people who've helped. Some of the slides I'm going to be showing, I've stolen from them. A lot of the ideas I've stolen from them. And there are a lot, obviously, this is just a core set of the people. I've learned so much from many other people. And I hope this doesn't just reflect the Smart City Systems Committee, but also a number of other standards groups that we're working with to try and tackle smart city issues. Next slide. So I'm going to be very, very simple here. I should have said earlier that there's a lot of slides that are attached to my presentation that I'm not going to cover, which go into the kind of depth that the other presenters have gone over. And also I'm going to be referring at the end to a newly published IEC technical report on a standards collaboration around ontologies for smart cities and smart city systems. And so that also will provide much more detailed content that will give you the kind of foundation to what I'm saying. But just being very simple at a high level, there is a lot happening in a city. We've got many different systems in the city. We've heard about health just now, and we know that a city depends on many other systems that all need data, increasingly need data to work well, and are collecting, therefore, lots and lots of data, using it to manage the different aspects of the system that they're involved with. But it's also really important to remember that each of these systems in a city interact with each other. And you can't see these things as silos. The data that's being collected in one city can be in one system can be enormously valuable in the other systems. Next slide. So, going forward, yes. So when you think about what a smart city is, there are, of course, many, many definitions. One of the ones I like is from ISO-IEC 30145 Part 1. And this points out that a smart city is an IT-intensive system of systems. Fine. This is the key thing. At a very high level, it can be viewed as a set of business processes that are integrated for the judicious use of sophisticated IT capabilities to realize outcomes. And so it's quite useful to think of a smart city not just as something that's using lots and lots of high tech, but much more as being one where the transformation is taking place in the way business processes are managed, because that we're able to use the sophisticated IT and the ability to gather so much data now and to analyze it and to use that to predict and to help guide the ways forward. So we can really see a smart city as being a city that uses data to help integrate and transform the business processes in the city. That's not just the processes internally, if you like, where the different people responsible for the different city systems use data to help manage that particular system, but it's also about how a smart city can enable the citizen to access city services and navigate their way around the city in a much better, in a transformational way. Next slide. So increasingly, cities are seeing the need of setting up a local data sharing ecosystem to enable all the data that's been gathered by these many different silos within the city to be brought together. And in order to allow that kind of greater holistic insight into what's going on and how different initiatives in one system impact on initiatives in the other. And that used to be, we used to think of data warehouses. Increasingly, there's been the idea of data lakes, where lots of data is being brought together and put into, if you like, a single space or single place where agencies can kind of fish or whatever, however you want to put it, take the data that they need and use it to gather the insight that they need. But then increasingly, we're looking at data spaces where it's not about data being put into one place, but where you're setting up ecosystems where governance rules are set up and common standards are put in place to allow agencies to continue to manage their own data, but to make it available, findable and usable by other agencies to enable that sharing to take place, but without using the control that is really important for agencies to have over the data that they're gathering. Next slide. So this is the challenge. We've got many different city systems, and of course, as we've already heard so well, even within each city system, like healthcare, they're very complicated. It's not just there's one single agency managing healthcare in a city, or energy, or transport. All of these are managed by ecosystems, sometimes many hundreds or thousands of organizations that are all involved in developing different aspects of that particular system, and they themselves need to be able to share data effectively, which is, as we've already heard, really difficult. But then we've got to try and bring all of that data together from these many different sorts of systems so that they can become useful by the city as a whole. And that's, of course, where semantic interoperability is key. Next slide. So, we need a city ontology. I'm going to cover three different of the many different things that are being done to help manage semantic interoperability. I'm just going to cover three things in this presentation. And the first is the need for a city ontology to help us understand and see how everything in the city fits together. Next slide. So ISO 37105, developed by TC268, provides a descriptive framework for cities and communities. And I love this because it shows in one single slide all of the key systems and aspects of the city and their relationship with each other, so that you can, in that one glance, get a good sense of what are all the things that we need to be thinking about when we think of managing the city, and how all of these different things link together. And this standard not only provides a very useful human readable description of what all of these different systems are and how they relate to each other, but next slide, it provides a city anatomy ontology to go with it. So a machine, it replicates that whole set of descriptions about how the city fits together and works together with a machine readable ontology using OWL and all the things that we know so well. And this is obviously just one of the many diagrams that there are to show all of the linkages between them. And of course, this is a really important thing because it provides a common, if you like, very high level framework to help everybody as they think about how to describe how their little bit of the system works and how they need to interact with other bits of the system to have a common way of talking about all of these different key issues in the city. So this is one key thing that we've done and need to continue to build on. Next slide. So the other challenge, of course, is the one that we've been mostly looking at here, and that's how can we combine data from different city systems to gain the added insights that we need. Next slide. So I'm just going to cover two different approaches here. ISO-IEC 30182 and ISO-IEC 5087 series of standards that's in the process of being developed. Both of them obviously are really focusing around semantic interoperability. So ISO-IEC 30182 is focusing on how you can take the many different terms that are used in each of the different city systems and try and isolate a few common core concepts that are behind them to allow you to, if you like, map the different issues or the different terms, the different concepts within a particular city system to something that becomes common to all of them so that you can get an overall picture of what's going on and to support high-level system decisions about how things should be done in the city. So that's one approach. And the other approach is the 5087 series, which is much more about a precise definition of common terms to allow cross-sector big data analysis, digital twins, AI, and so on to be delivered and used by the city. Next slide. So let's look a bit more about ISO 30182. What that obviously points out is that data is often labeled using language and terms from the department or agency that initially collected it. And there's specialist terms are being used in each of those sectors. And each sector will have its own models and terminologies that enable data to be discovered and understood within that sector, but which form a barrier to interoperability with other sectors. Next slide. So, as we can see, in health, you have a doctor, a patient, clinic, treatment. They're clearly specialist terms. This is very much looking at a high level here, of course. But you can see in education, you've got the same kind of roles and concepts labeled differently. So you've got a teacher that delivers the service. You've got a pupil that's, if you like, receiving it. You've got a school where that takes place. And you've got education, which is what you call the aim of the whole process. And you can take that really into any single system within a city to see how you can take these specialist terms and you can see that behind them are common concepts that, if you can only map them together, can help understand how things are being done more completely. Next slide. So what the 30182 does, it defines a smart city concept model, which is a high-level framework of concepts and relationships that can be used to describe data from any sector, and then allows you to map terms from different sectors onto that high-level framework, which provides a basis for discovering and sharing data about the same thing from many sources. Next slide. So, here's an example of one. So within health information, subject of care, there's a definition, and that maps to the concept model of person. And you can go all the way down. They're very simple. They don't contain anything like as much detailed information as the actual specialist term contains. But what it does do is it focuses on what the core aspect of that term is about. Next slide. And then, of course, you can start to map the terms together, so you can get high-level data models and so on to see all the relationships between these different terms. And then next slide. So just losing that service concept, that kind of high-level way of doing it, it allows me, as I map the services provided by all the different systems within the city, as I map it to that high-level service concept, it allows me to find out all the services that are provided to a specific community, where, when, and how they're delivered, what are the agencies that provide them, what are all the services a particular person is eligible for, what services a household is receiving, what's the cost provided to a community or an individual or a household, and I can provide these in machine-readable formats to be easily discoverable. So what this approach does, it simply is a very good way of giving an overall picture of all the different services that are being provided in the city to give a good sense of whether they're being distributed in an equal way, that what sort of costs there are, and to make much better decisions to be made about the overall management of the city and its resources. So that's a really, it may sound very simple, but it's a very important and valuable resource that cities can have. Next slide. So as you see, lots of, I won't go through them all, but it has many, many benefits in doing this, and that it really enables and supports that kind of big picture decision making within the city. Next slide. Then the ISO-IEC 5087 series, which is about developing common data models or agreeing common data models, so that makes it much easier to link data sets and data streams from different agencies and so on to be combined. Next slide. It talks about the, I guess does it show, yeah, if you just build them all up, it talks about the silos, and as we've already seen, that's already an oversimplification. And of course, each silo is collecting data separately. Next slide. But what we need, of course, is in many particular decisions in the city, you need to engage with many different systems. So, for instance, if you want to pave a road in a city, it's something you need to have transactions. You need to have processes in place that you can interact with all of these other different systems in the city to make it work. You need coordination, and you need cooperative problem solving. So you need consistency within the data. Next slide. So we need some way to enable that to happen, which means some sense in which we can integrate as far as we can a city data model and the data in a common way between these different systems. Next slide. Oops. Yeah, there we are. Thanks. What the series are doing is looking at, if you like, city data on 3 levels. The foundation level is about general concepts such as time, location, activity, events, resources, and units of measure. And obviously, there are many standards around how you describe these things, particularly World Wide Web Consortium, but also others. And what this is about is bringing together recommendations to ensure that all agencies in the city use the same set of general concepts. Then you go down to the city level, where you're looking at concepts that are general to cities, but which span all the different services, if you like, within the city. So, if you like, the concept of household is something that's important to to health, to education, to transport, to energy supply, and so on. So that tries to identify what are those common concepts that need to be used by all the different services within the city. And then it goes down to the service level, where you're talking about concepts which are much more focused within the different system level, where they need to be developed by the owners of that, or the people running that system, because they're the experts on that particular area. But that they need those data models to be made available to all the other systems so that they can have a common way of dealing with these things. Next slide. Now, this is an important piece of work. In a way, we may feel it's almost doomed from the start because we've been talking about the challenge of different, of getting people to align on data models, and it's a very complicated way of doing it. But the key thing here is that we all need to work together. We, like you, are facing huge challenges. And so because of that, within Smart Cities standards bodies, we ran an international virtual seminar on standards collaboration on ontologies for smart cities and smart city systems in September last year, where we brought together over 2 days ontology experts from many different technical committees. The first day looking more generally at what was being done in standards bodies around ontologies, and then the second day focusing it much more down on smart city issues. And as I've mentioned, really rich content there that you can get from this newly published technology report, which you can download obviously for free there, and see, get something of the richness of what we found out from bringing these group people together, like as we found out today in this workshop. And I think one of the key things that came for me out of this workshop was that we found many people representing different working groups within different technical committees that were working very hard to solve one particular issue around ontologies, and had no idea that there was in another technical committee, another working group that was tackling or trying to solve the same sort of issue. And there was so many times that people say, wow, if only I had known, or if only we had known what you were doing, we could have collaborated. And I guess that's a really key fundamental lesson I think that's also can come out of today. Next slide.
Michael, and on that note, if it's possible to wrap up, because you've reached your 20 minutes.
There's two very quick slides. I should say there's a long set of slides on that. Just one more, if you don't mind. Being pragmatic, we've talked about the challenge of helping ensuring that all these many different agencies will follow the same set of standards. So final slide, please. So we've been trying to work at minimal but good enough interoperability. So can we think of a small set of requirements that would help to make it easier to make some kind of sense of all this chaos? So that there's a number of things that you'll find there that we're trying to do to at least try and help to align the work that's been done to make it easier to bring that interoperability and integration. Thank you so much. Thank you.
Thank you, Michael. And once again, very full, very busy slides, lots of things to talk about, and these will be made available on the website later on. So I then move on to my second to last presentation, which is supporting information exchange, semantic interoperability in smart manufacturing, ISO-IEC-CDD. And I think that's Hiroshi Murayama. Sorry about my terrible pronunciation. Over to you, sir.
Can I use your presentation or mine?
It's Kevin who's managing this, and I thank him very much for dealing with all that today. Can you put the slides on?
Okay. Who?
We haven't shared on the screen.
Okay. This is the joint work between myself and Gavin Rossi, who represents the IEC side of the Common Data Dictionary. Common Data Dictionary here means almost a synonym of the ontology. Okay, please, next slide, please. What is CDD? A CDD is a cross-domain product ontology registry for both ISO and IEC product, including services. Namely, it's a database that integrates and archives changes over time of ontologies of different domains based on different ontology models provided in multiple languages, not just in English. Not a snapshot of the latest things, but accumulation of the changes of ontologies over time. That is the CDD. Secondly, CDD is based on a common dictionary schema developed between ISO and IEC. One is 3580 for part 42, and another is IEC 61360 part 2, and also extended by IEC ISO 3580 for part 35 and IEC 6266 part 1, known as a parcellized ontology model. Okay, it was agreed that the CDD serves as a common repository for ontology based on these standards, or transformable to these standards. Okay, the changes to the registry is being done by change requests, not by standards. So this is also a different things from others. We are using, in case of IEC, the supplementary directive, IEC supplementary directive Annex SK, and in case of ISO, CSP, committee specific procedure for the CDD. So we are, through the change request, changing the content of the CDD onto the registry. Okay, next slide, please. We are collaborating with many TCNSCs in ISO and IEC. Notably, IEC TC65, they have developing so many standards, more than 10 or 20 ontology standards there, and still continuing to develop that. And also, it is written as SC 17B, but currently it is IEC TC121, I think. They are developing standards. Okay, with this way, we are collaborating with many TCNSCs. Okay, next slide, please. Okay, why ontology is necessary? It is evident for many people here, but you cannot model everything in the information model, especially the what does a product means, what are each property means. These need to be provided in a separate database. That is, in our case, the IEC-CDD and the content of the IEC-CDD database. Next slide, please. Okay, in the ordinary business, of course, when you buy things on the website, for your daily matters, you have already used these things, so you have experience and you know what does it mean. But when you try to buy or try to get some information about the technical content, technical things over internet, if you don't have the common understanding about the technical terms, it is very difficult to get the precise information from the website. And you can order things, you can specify things according to the information provided on the website. So we need to have the common understanding about the terms and meanings of the things. Okay, next slide, please. Okay, this is just a view of the IEC-CDD. You can get the same view from your PC. Okay, just the introduction of it. Please go into, okay, wait there. And the one interesting thing is that you can see on the screen, not just English, but you can have some French, German, or Japanese, and currently Chinese translation is provided. Not for every definitions, but if there are translations of the content, then Chinese, Japanese, or French, German translations are available. Besides the English one. Okay, go to the next slide, please. Okay, so under the CDD, it was originally IEC 61364 DB as container. Then there are so many ontology standards being stored. One recent addition or being projected or being carried out is ICS, International Classification for Standards. So classification of the standard itself is being introduced into the CDD through change request. It is already entered into the test area, and we are running the evaluation and validation. Okay, that's the current situation. Okay, So in the next slide, the same thing. For IEC standards or IEC ontologies, Annex SK, in the Annex SK of the IEC supplement of the Directive Part 1, there is a procedure how to make content not through the paper standardization, but the database-based standardization process. In case of ISO, there is a committee-specific procedure for CDD, and using this procedure, we can update the content or propose the content to the CDD without going through the paper-based time-consuming process. We can do it within 4 to 6 months currently. Next slide, please. Okay, since 2007, more than 120 change requests have been proposed, and each year 10 to 20 change requests on average. Okay. Actual submission is done with a bunch of Excel sheets, precisely defined in IEC 6266 Part 1 standard, but also available in XML schema and JSON that are defined in IEC 6266 Part 8. Okay. And these change requests are managed in case of IEC. In case of IEC, it is IEC SC3D, I think IEC VT, validation team. And so in case of ISO, it is ISO TC14SC4W25, which is mirrored in IEC as a VTI ISO CDD under IEC. There is an effort to use the IEC maintained database by the ISO committees. That is mechanisms that currently invented. Okay, next slide, please. Okay, this is just a view of that. Organizationally, ISO TC14SC4W2 WG25 members are copied into the IEC SC3D VT ISO CDD team or WG. And so separation of ISO rights, ISO experts right and IEC experts right are separated in this way. Okay, next please. Slide please. Okay, just to explain. Well, in case of normal paper-based or e-paper-based standards, starting with the scope, etc., and the rules and principles, etc., then the actual definitions start, and the actual definitions of items follow the same pattern, and that can be put into tables. And if you can put into tables, you can put it into the CDD. Instead of writing all the details in your paper standard, create these tables content in the CDD through change requests. Then you can just take 5 to 6 months or sometimes 4 months to put the content into this CDD, and then it becomes part of the international standard. That's the advantage of making the standard more flexible and makes it in a shorter time frame. Okay, next one, please. Next slide, please. Okay, as I said, we are putting the ICS into the international classification standards, and every standard in ISO IEC has a ICS number. So therefore, if we have the classification of ICS in the CDD, then all the standards can be searched through the ICS number. That is the idea, and we are in the process of validating the ICS change request. If we add the standard profile database, then users can search. Users can find the relevant standard through the ICS number. Let's will add some advantage to the ICS. Okay, next slide, please. Next slide, please. Okay, I'll skip this because it is too much in detail. So please skip this one. Please skip this. Okay, this one. What we can handle in the data model is not just the ontology at the level of here, domain ontology or domain dictionaries. What is important is that the data model itself can be treated as instances, because as I often hear that we use the object class, we use blah, 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 etc., etc. But actually, when we are almost talking about the same thing, so if we map correctly the data models, we can handle all these in a single framework. That's the basic idea. And using these mechanisms, we have registered so many ontology contents into a CDD. Next slide, please. Okay, this is an approximate view of the concept in the 6265 part 1 standard. Everything is a class. Okay, concept is a class, and class is a concept. And there are so many relations in ontologies, but relation itself is a class. And when we see a specialized one of the relation is a function, and property is just a function. And classes describe the properties. And when you have arity 0 of the function, it is the constant. Individuals are in fact the function of the arity 0. So everything is the specialization of the class. Then by the single notion, we can simplify the things and model almost all the things within a single framework. Okay. Next slide, please. Okay. Maybe it is too much specialized, but okay. Okay, I'll skip this. Okay. One of the problems with the semantics is that sometimes meaning depending on the terms, and what I mean to say is that a fly is on the ceiling in English can be translated into European languages. But on is used here, but in the precise sense, there is no on counterpart in Japanese language. So is on is used as a function. You cannot have this counterpart in Japanese. So if you break down the things into a descriptive logic, we have problems with these translations. And this is common sometimes with the Chinese language and Korean languages. So depending on the language groups, what can be said within a sentence is different. Also, the concept of green and blue are mixed in case of Japanese language. So when you say blue, it's when you say green in English language, it is sometimes explained by Japanese as a blue. This kind of the confusion occurs with the translations. So when we consider the multi-language ontology, we should mind about the translations. And the second thing is that what second thing I described, an octopus uses 2 halves of coconut shell to hide himself, where no language is used by the octopus. But he understands the concept of both is a halves of the coconut shell is like a shell and has a coconut has two halves, or the shell in which it hides has two parts. These kind of basic concepts are known to animals without using language. That's something we have to keep in mind. Not everything can be expressed by, or not necessarily expressed by, the languages. And also, a bird picks a ripe berry from a tree. It differentiates the part from the whole and recognizes its color without speaking or reading language. When we apply this ontology type of things or semantics of things, it is not necessarily decompose a logic into languages. That is something to remember. Okay. Please, next slide, please. Go to the next slide, please. Okay, IEC-CDD is available from this side. Okay, next slide, please. Okay, that's the end of my presentation. Yeah.
Okay, thank you very much. Again, we've got the last 20 minutes, so again, not possible for any additional questions, but some interesting philosophical thoughts as well about understanding and language. Right, and I would like, if we can, get to our last presentation. We're in time. We've got 19 minutes, which is 4 minutes more than you originally planned, so I'm very pleased with that. The importance and challenges of interoperability. Notes on the 20-year quest for semantic interoperability in financial services from Jim Naughty from ISO TC68. So over to you, Jim.
It's okay. Can I share my PowerPoint here? If you don't mind, I'll drive. Can you hear me?
We can hear you. Very quiet though. If you can get closer to the microphone or speak louder, would be helpful for my hearing.
Yeah,
even a little bit louder, but I'll let you get started.
Okay, thank you very much. Okay. Yeah, thank you. My name's Jim Northey. I want to thank all the other presenters. I think what's something very important here is that I think we have some takeaways that we can follow up with the group.
It's really, really quiet. Are you able to make yourself hearable, Jim, please?
Yeah, just let me see if I can make any changes here. Just a moment.
Really, really quiet. You're whispering to us.
Okay, let me try to look at the audio settings. Just a moment. Output level. Okay, is this any better? Just testing.
I think it's better, but I've increased my my speakers. So.
Okay. Yeah. Unfortunately, I think this is about as good as I can get right now with the sound. So I hope everybody can hear me. I'll try to speak louder.
It's much better, thank you, Jim.
Okay. Is that better? Okay. Good. Okay. So I'm going to reshare my my screen then. Okay. So we just a little bit of background on ISO TC68. We serve the entire financial services industry. We have 3 subcommittees where most of the work is done: information security, reference data, legal entity identification, financial instrument identification. And one of the things I think that a takeaway from this for me is that I've always found that there's many syntaxes and languages, but really at the data element and the identifier level, if you can solve the individual data element problem, you can gain a lot of interoperability and benefits from that process. And then we have SE9, which is where our ontologies live and our important messaging and interchange standards live. So trying to get the there page down. Just to give you a breadth of TC68, we cover the credit card industry, capital markets, that's trading stocks, bonds, other equities, payments, foreign exchange, core banking, central banking. And then we also have a remit of trade services, but it's an area which is really underserved by TC68 now. And I think given the technological direction of where some of the things that UNECE-IEC-ISO is going is we have a long history working with UNECE-IEC-ISO. We might be able to do some more work there in the future. So we go to the next slide here. I'm going to move through this next slide just to give you an idea of, again, the scope of the system. And I wanted to also show you the need for interoperability here. TC68 operates with a number of committees. The liaison out, you can see the number of liaisons, including SC32, who just spoke. Also, given the evolution of finance, we have need to work with TC307, TC309, TC322, and we recently added a liaison out to SC42, which is for artificial intelligence, which I hope I'll make sure to properly budget my time, because I really want to follow up on something that Steve Capel said earlier, which I think is vital. So this is TC68 again, and I also wanted to emphasize the need for interoperability given the number of liaison organizations, all which many of which have their own standards efforts that go on. And as you can see there, finance is at the hub of a lot of activities, and you can just go down the list there. And I'm not going to go through this now, but you can definitely see the need for interoperability here. So I want to move on. So I want to mainly talk about our way of communicating financial services, transactions, and messages. It started with, in terms of deep ISO standardization in the 1990s with ISO 15022. As soon as we got that standard created, the XML explosion happened. So part 2 was created. Then we learned that we couldn't use that, so we renamed it to ISO 20022, and that is the primary messaging syntax for financial services transactions globally across many areas of financial services. But it's more importantly, ISO 20022 also contains our key business model, and there's just a reference is available on our website at iso2022.org. And we're in the process, I just want to make sure people understand ISO 22. It just describes a platform for developing of messages, but importantly, it also contains our key business models and business definitions. And at its basic, the output which is usable is the XML and AS1. We've since extended that to JSON and APIs, which is important. And very similar to what other groups have presented, and I want to move through this fairly quickly because you can go look at this for yourself, is that we have this notion of business components, and those business components then map onto the other business components, and then they map into messaging. And so we've been on a quest for semantics for quite some time. If many of you on the call might remember that the MOUMG ran an interoperability trial using semantics web technology, and Jamie Osborne and I represented ISO 20022 in that, where we tried to work and actually harmonize on a set of concepts across multiple organizations. And I have to say, one of the things that I found challenging as being one of the champions for bringing semantics into ISO 20022 is that there is a big gap between the usability of the tool sets in the W3C web stack and what everyday practitioners are able to use and be able to work with. And then that's only confounded by the difficulty it is. I think we spent 6 months within the MOUMG exercise about a decade ago, just trying to standardize on postal address across multiple organizations. So So one is the amount of work that goes into it, and the second thing is the lack of tooling, and also I think the lack of ability for people to use that tooling. So I'm wondering if there's not another approach we're going to find that's going to be taken. I'll talk about it the last slide. But we started in 2004 when we revised the 20022 model, and at that time, actually, we had a group of people who wanted us to move to the web ontology language, OWL, as the basis. At the time, it was felt that the industry was not ready for that, and we didn't move to that. But about 10 years later, we set up a working group that I led, who's now led by Lisa Taiketsataporn from the FIX organization. We're finishing up our work there, and it's still trying to bring semantics into ISO 20022. I'm thinking that maybe some of the lessons learned and some of the sharings done on this slide, I'd like to take back, and it may actually help us to further along with this. But we're now in the process of starting to revise ISO 20022 again. But I'm not sure yet that the community is ready to take that semantic leap, if you will. So where are we now? We do have some W3C based semantics. And the ISO 17442 legal identifier, entity identifier actually went with an ontology through schema.org. The legal entity identifier is designed to be a global legal entity identifier with a registration process to be used cross industries. And again, that whole notion that identifiers can be a key use of interoperability across different entities throughout the various life cycles of businesses that are done in society. And then in the ISO 10962, we actually went through the W3C way. It's a very, very complicated structured code set hierarchical model. So we actually built an ontology of the code set itself, and we use SCOS and OWL to actually deliver an external representation in the terse tuple language, TTL. So those are some, but I think the key need for interoperability, our opening slide showed UNECE-IEC and OAuth processing. That often culminates, that starts with some kind of credit event at banking, and then it ends in some kind of payment or settlement process. And all of that is ISO 20022. For us to fully have a seamless, secure, and process that doesn't have interruptions where you can either have failures of delivery, failures of payment. I think interoperability is really key. And the main message I wanted to leave with everyone, and it's a short one, is I wanted to talk about what Steve brought up. And I think that our goal may need to shift more back towards something like an ISO 11179, where we get the data in a format that's readable in a semi-structured manner by generative AI systems, so that we can actually employ those tools to actually do the interoperability. Given 20 years of trying to bring this technology into the financial services industries, I'm really very reluctant to say that I don't think that the practitioners who are involved in the standards can actually adopt the W3C web semantics technologies. But we now have some tools with the various large language models that could be trained to actually provide that level of interoperability. And I think we need to look more towards having our data discoverable in a standard format of concepts using something like ISO 11179, and allow the tools to do much of the work that would be impossible for humans to do. The one strong benefit that I want to share with you that we think we've seen, and I hope it will come into play in this next version of ISO 20022, is that XML, UML, of which both are used for our current ISO 20022 standard, they're both single language specific. It takes quite a bit of work to extend these to other natural languages. When you have thousands of ISO 20022 messages in Chinese, primarily used by Chinese speakers, when we have hundreds of messages used in Brazil, used by Portuguese speakers, we need to make it so that natural languages can be a first order property. And one of the beauties of RDF, of course, is its ability to actually have, as close as possible, natural languages being on a first order basis. I was really intrigued, very much so, by the last presenter, Hiroshi, because I think he raised an interesting point that's going to probably change. I'm going to take back to our groups, and that's the notion that it's not just enough to be able to support a natural language translation as something vital. Clearly, it's vital to have those natural language translations, of which we do not fully have yet in ISO TC68 in our interchange and messaging standards. But more importantly, being able to make sure that we're also compatible at the concept level and the basic language structure level. I think what I've learned there is something I'd like to take back to our groups, and just shows the power and value of the MOUMG, by the way. So one of the things we did, Don Mendelson, who used to be the technical architect for the FIX trading community of the FIX protocol, which is an active member of ISO TC68, was he just took basically ChatGPT 3.0 and asked it to map the FIX order message, which is a standard for electronic trading of stocks and bonds and derivatives and futures, things of that nature, to OUCH, which is a proprietary standard from NASDAQ, which is one of the major exchange groups globally. Okay, no training, no additional information. What surprised us the most was, without any specific training, the mapping was as high a quality as I've seen anybody else do who are trained practitioners in the field. Now, this has led me to believe that maybe the most important thing for us to do is to make sure all of our concepts are organized in something that's reasonably consumable and understanding by these generative AI products, and use that as a path to interoperability. So that's really what I wanted to wrap up with. So again, just to recap, we've been working and struggling for 20 years trying to achieve some kind of semantic representation and open up our standards. I think many of the presentations we saw today will help us in TC68 maybe make some further inroads following what some of you folks are already doing. But the key thing, I think that the need for interoperability is only increasing. And especially at some point, there has to be some kind of, unfortunately, most things end up in some sort of financial transaction. So our need for interoperability is quite high, and that the promise of generative AI and large language models are something that I think the MOUMG should start to focus on, and maybe look at how we can actually start to interoperate at that level and make our models available to that system. And with that, I think I'm going to stop now so that we have a couple minutes to wrap up the presentation. Thank you very much for your time today.
Okay, thank you, Jim. And as you rightly say, we've just got 2 more minutes to the end. So first, I'd like to thank all of the presenters, all of the presentations, the quality, the great feedback, the identification. I think we can clearly see that across the board there is a need for semantic interoperability. There is certain things which come with it. There's we're talking about libraries, governance mechanisms, creation of components to build up. I don't know, I'm trying to think of other good words and things. I've written a copious amount of pages, to which I will hopefully convert to some output report and also make that available on the web page. And we'll be following up with with all of the presenters, whether or not there's a need for follow-up, another webinar, something wider, something or more focused. That's something to look into. The material will be made available on the web page, as I've kept on saying, and you still also have the ability to send any questions either my way or the last 30 seconds to put on the chat. I'd also like to thank very much Kevin Bishop, who's been the person behind all of your presenting all your slides, for those people who allowed us to present your slides on the screen, and did all of the all the lovely work in setting these things up, etc., as well as my other stakeholders in the MOU. And for that, I'll finish on time. It's 3 o'clock on my clock. And once again, thanks everybody for presenting, attending, and hopefully you found it both useful and something to follow up with. Thank you.